Karen lives 2 blocks west and 1 block south of the southwest corner of City Park. Her school is 2 blocks east and 2 blocks north of the northeast corner of City Park. On school days, she bikes on streets to the southwest corner of City Park, then takes a diagonal path through the park to the northeast corner, and then bikes on streets to school. If her route is as short as possible, how many different routes can she take? Pause the video and see if you can solve this on your own. Here is a diagram. Her school is here, and her home is on the bottom left corner. This is the park. All right, what answer did you get? Well, here is the solution. We know that the keyword here is if her route is as short as possible. We first have to determine what is an example of the shortest route. How many units does the shortest route take? We know that she always crosses through the park diagonally, no matter what, so we don't have to think about that. All we have to do is look at the 2 sections here. What is the shortest possible amount of ways to get from this point to this point? Well, that would be 1, 1, 3, and you can't really get any less than that. You always have to travel 3 units, unless you're for the shortest unit. So you could do 1, 2, 3, 1, 3, 3, 1, 2, 3, for example. So here it would be 3. And then, what is the shortest possible route here? Well, you could go up and then right 2 times. So 1, 2, 3, 4, or 1, 2, 3, 4. So you can't really get any less than 4 units. So 3 plus 4 plus the park. This is the length of the shortest possible route. Now, you'll see that in these 2 areas, as long as we travel up or to the right at any single move, then it is always going to be the shortest possible route, at least as long as we don't go left or go down, right? As long as we keep going towards the school, it's going to be the shortest possible route. So that's basically what we're dealing with here. So how many possible ways are there for home? Okay, so here is home, and it's made up of 2 grids. So this is our starting point, this is our destination. Well, we could use the method we learned from the last video. There is one possible path you get from the starting point to this point right here, and there is one possible way to get from the starting point to this point right here. For this point, all we have to do is add 1 and 1, and we have 2. And now for this point, the only possible way is if we go right 2 times. So again, there is a 1 here, add 2 and 1, we get 3. So there are 3 possible ways for this area. Now we have the school, and our school is just a 2 by 2 grid, right? Our destination is here, our starting point is here. Well, we always know that on the sides it's going to be 1s, and then we start adding in the middle. So 1 and 1 is 2, 1 plus 2 is 3, 2 plus 1 is 3, 3 plus 3 is 6. So here there are 6 different ways. Now is the question, is it 3 plus 6 or 3 times 6? What do we do with these numbers? Well, it makes more sense to be 3 times 6, right? Because previously we learned about making combinations. So it's like if you have to make a mixture of A and B, right? And for the first option, you have 3 options. And for the second option, you have 6 options. You don't add 3 and 6 to see how many different ABs can you make. You just do 3 times 6. So that's the same thing here. There are 3 different possible ways for the first area. All of this is a bit abstract. And there are 6 possibilities for the second area. So 3 times 6 would be 18 different paths. So 18 would be our final answer.